Welcome back. Good news for you. We're actually going to use this stuff now. And better news for you is I'm super hungry and I want to eat lunch, so I'm probably going to do this quickly. So let's go ahead and use a polynomial function to maximize a volume. The design of a digital box camera maximizes the volume. I love that word, but it keeps the sum of the dimensions at 6. The length must be 1.5 times the height. What should each dimension be? You can see we're going to be maximizing something in our calculator, so your brain should be thinking maximize. Here we go. Make your equations, and yep, this is the hardest part for students. So I can give you guidance. You can just stick with me. You can definitely pause and try it on your own. But here I go. I'm just gonna do it. They told me that I gotta consider volume. Well, volume of a box is length times width times height. This will be what we need to eventually maximize. What else do I have? The sum. Hopefully you guys know that the sum of the dimensions is, I just undid something. Length times width, oh, sum. Length plus width plus height, and they said that has to be at 6. All right, two equations, and I did that right here with this sentence. Ooh, and then they give us this little tidbit of information. The length must be 1.5 times the height. Let's see. The length must be 1.5 times the height. I love the fact that I have three equations and three variables, and I'm sure you feel the same way. Let's get everything in terms of, since this one's in terms of h, let's get everything in terms of h. Now remember, our ultimate goal is to focus on this one here because that's what we want to maximize. Let's see. I know, so I'm going to get everything in terms of h. I'm going to write that down. Get in terms of h. All right, well, L is 1.5h. That one's done. Check. Hmm. H is h. Check. Uh-oh. Width. The width is going to be the hard one to do. So let's think about this middle equation. I wonder if I could get width by itself. Like, what if I did W equals a negative L, a negative H, and a positive 6 by moving the L and the H to the other side? All right, well, that's close. Can anybody think of a way to get rid of that L and make it an H? I can. Look here, isn't L 1.5H? So why don't we write W equals negative 1.5H. I took away the L. Oh, that's horrible. You should judge me there. And I still have a negative H and a positive 6. And look, guys, I can combine my like terms. That's negative 2.2 looks like a Z, 2.5H plus 6. And yay, I can get rid of that question mark. I bet you knew I was going to, huh? And I know, is this messy for you or is it just me that's having a hard time? I'm doing that. I'm sorry, that was really messy. Could not stand that. I had to put that there. Let's shrink it down. Bring this little guy over because that's what I want. All right, sorry, zooming in. W is now negative 2.5h plus 6. And look, everything's in term of h. Yay, go me. I got very excited there. Some of you are probably very annoyed by me. I'm sorry, I'll tone it down a little bit. So remember how we wanted to maximize this formula over here? Remember how volume was length times width times height, and that was obnoxious because they weren't all in terms of something? Well, now I can say volume is, instead of length, 1.5h, instead of width, negative 2.5h plus 6, and then height can just stay h. Please notice that length got replaced, width got replaced, and height stayed put. There is absolutely no, I'm going to make an asterisk. You can multiply if you want to. You can multiply those together if you want. It is absolutely not necessary, okay? So I'm going to just leave them alone and I'm going to put that because I know I'm going to use my calculator anyway to maximize because that's what we do. I'm just going to put that into the calculator. And I will do that now. The problem is that my calculator is not the pro version. So I might have a little bit of trouble, but let's see. Um, so I would clear these out. Now, remember, please, are you still with me or are you sleeping? Please remember that your calculator does y and x's. So anywhere we have an h, our calculator needs us to do an x. 1.5x instead of h, negative 2.5x instead of h, and there's our last x. I don't know why I used parentheses. If I were to graph this, it's angry at me. Yes, it is. Let me take a look at my window here. Hey everybody, I was fighting with my calculator, so instead of fighting with it, I'm just going to use Desmos and tell you that make sure you can use your handheld calculator. I'm sorry, I don't have the paid version, so it is what it is at this moment. So I'm going to type them in here instead and edit that part out of the video. That'll be fun. That's okay. You don't even know there was another part of the video because hopefully I did edit it out. All right. Now, just in case I edited out the part, you're like, hey, you're not using H's, you're using X's. That's because your calculator needs you to use an X instead of an H. So we're good there. All right. Remember how I needed to, let's check this out. Find the min or the max, read your problem using your calculator or the website if you're at home. So this one definitely wanted the max. So let's take a look at the max volume. Well, this green line over here in Desmos represents my volume. Well, that was obnoxious. Let's see. Really wanted to zoom in. Yeah. Hmm. I bet it's fun to watch me struggle. Let's see. There we go. There we go, land jelly. Okay, I need to find the highest relative maximum. So that's going to be over here. I don't know if you can see where I am. I'm on the right side. I see a max happening at 1.6 and 7.68. And you'll have to use your TI-84 calculators for that. So what we just found was the value. I'm pretty certain that's good. Yep, it's happy. We just found the height and the maximum volume. So I will say that the maximum volume, there it is, the maximum volume is 7.68 cubic inches. And I will say that the height needs to be 1.6 inches. Now let's look. I wonder what the length is going to be. Because remember the length was 1.5, whatever I just got. Multiplying that together, 1.5 times 1.6 is 2.4 inches. And if you also remember the width was negative 2.5 of what I got plus 6. And if you multiply that together, you'll get 2. And sure enough, if you add these, you get 6. And if you multiply them, you get 7.8. And that is how you use what we've learned to your advantage. All right, remember how I told you I was hungry? What I'm going to do now is I am just going to walk you through this one. If you want to write it down, go ahead. You're going to see me solve it in probably about 3 minutes. A rectangular box has a square base. Ooh, that means x by x. The combined length of a side of the square base and the height is 20. Okay, so I'll just use h for height. Let x be the length of a side of the base of the box. Well, that was convenient. Write a polynomial function in factored form, modeling the volume. What is the maximum possible volume? Make my equations. Okay, I'm going to do this one. The combined length of the sides of the square base and the height. So that's going to be combined length of the sides of the square base of it. I better learn how to read. Combined length of a side and the height is 20. and they want me to have a volume to maximize. So that's going to be length, width, height. Well, the length and the width are both x's, and the height, let's see, let's see, let's see. Can't the height be 20? Take away x from over here. So take away that and do 20 minus x. It says write it in factored form. Oh, we did it. So in factored form, that's x squared and 20 take away x. That accomplished the red that they needed. And set that equal to 0. All right, we're going to set that equal to 0, put it in our calculator. Now let's just go to Desmos because my TI-84 calculator on my iPad is not the paid pro version yet. And let's see what we get. Y equals x squared, 20, take away x. And they wanted me to maximize that. Well, let's see if we can. Whoa, whoa, whoa. That is crazy. You guys see that max up there? Thank you, Desmos. Oof. What is that max up here? Are they going to let me? Yes, they are going to let me. I see that the x value should be 13.33 inches. Are we in inches? Yep. And I see that the max volume is 1185.185 cubic inches. And do they want anything else from me? No, actually, part B, they only wanted the volume. So there it is. And as long as I typed everything in right, x squared, I did, and I found it. Thank you, Desmos. Make sure you can use your T84. We're done. I hope you've enjoyed 5.2. I know it was a little lengthy, but believe it or not, this is the much more condensed version that I used to give. Have a great day. Can't wait to see ya.